Hi, this is George Braswell, and I am presenting Security Framework assignment number 2 from CYB690. And here we go. Cybersecurity environment. So, explain the current cybersecurity environment for Stark Industries, my company. It includes the following business critical processes, such as the ongoing development research into future weapon platforms being conducted by the R&D department, which includes the virtual development environments or VDEs operating on servers located in the Stark data centers. We've got on-site engineering workstations, air-gapped workstations, and various benches for prototyping and testing, which also includes some connected workstations. All the R&D systems minus the air-gapped workstations are interconnected, and they do require 24/7 availability. These systems are processing classified and unclassified data as well as handling intellectual property, which is critical to the company. Also in the environment, financial and business systems necessary for the business management organization where PII and confidential company information are stored and processed. And all this data is encrypted as it goes through its various phases throughout the company. Next slide. Risk management, development threats, legal regulatory requirements, etc. As a defense contractor, Stark Industries is subject to DFARS, which is the Defense Federal Acquisition Regulation Supplement, FISMA, the Federal Information Security Modernization Act, and the NISPOM, the National Industrial Security Program Operating Manual, and uses the NIST cybersecurity framework to manage risks and meet legal and regulatory requirements. So, as you may recall, the cybersecurity framework from NIST involves the 5 steps: identify, protect, detect, respond, and recover. And under those, Stark Industries, for identifying, they've identified the system's assets, data, and personnel critical to its operations and assess the potential cybersecurity risks associated with each of them. Those systems are going to include those engineering systems for research and development, as well as the financial systems and anything related to manufacturing and production of weapon systems, aerial platforms, anything else of that nature. The assessment includes understanding the DFARS requirements related to controlled unclassified information or CUI, FISMA requirements for categorizing and assessing risks of its information systems, and NISPOM requirements for protecting classified information. For Protect, based on the identified risks mentioned above, legal and regulatory requirements, Stark Industries has implemented protective measures such as access controls, network segmentation, encryption firewalls, and IDS and IPS systems to safeguard its systems, data, and personnel. Company has to specifically comply with DFARS Clause 252.204-7012 and the implementation of NIST Special Publication 800-171 controls to protect the CUI, FISMA requirements for minimum security controls, and NISPOM requirements for protecting classified information. Once again, in detection, Stark Industries uses various detection tools and techniques, including network and system monitoring, log analysis, IDS, IPS systems, SIM, and incident response processes to quickly identify and respond to potential cybersecurity incidents. For responding, Stark Industries has a response plan in place to address potential incidents, including a dedicated incident response team or IRT, various communication protocols for communicating within and without external to the company, and procedures for containing and eradicating any threats that may arise. Uh, we also have we're in compliance with DFARS and NISPOM requirements related to incident reporting and classified information spillage. In recovery, step 5, Stark Industries has also established a plan for recovering from a cybersecurity incident, including data backup and restoration procedures, system recovery plans, and business continuity plans, or BCPs. The company is also in compliance with NISPOM requirements for reporting security incidents, including procedures for handling classified information spillage. Additionally, regarding organizational constraints, Stark Industries, being subject to DFARS, FISMA, and NISPOM, faces additional challenges related to the classification and handling of classified information and CUI, which impacts how it implements certain security measures. The company must also comply with other legal and regulatory requirements related to export control, ITAR, which is the International Traffic in Arms regulations, and other security and compliance requirements, such as the Cybersecurity Maturity Model Certification, or CMMC, which is currently on CMMC 2.0. Best practices and frameworks to develop a cybersecurity program. Step one, identify the applicable framework. First step is for developing the program is making sure you pick the correct framework for the organization. This could include frameworks such as the NIST at 800-53, ISO or IEC, ISO/IEC 27001, CIS controls, or other industry-specific frameworks depending on the industry. For Stark Industries, it's the NIST Cybersecurity Framework, or CSF. Step two, conduct a risk assessment. Once the framework has been chosen, a risk assessment has to be conducted to identify any potential cybersecurity risk. This involves identifying assets need to be protected, the potential threats and vulnerabilities that exist, and the impact of a cybersecurity incident on those assets. Step three, develop a cybersecurity plan. Based on the results of the risk assessment, you're going to develop that cybersecurity plan to address the identified risks. This could include policies, procedures, and controls that are tailored to the specific needs of the organization and aligned with security framework. Step four, implementing the plan. Once the plan has been developed, next you have to put in new action. This includes implementing access controls, encryption mechanisms, security monitoring tools, incident response plans, and employee training programs, which is critical as human beings are often the weakest link in cybersecurity. Step five, after the plan has been implemented, it's essential to monitor and review the effectiveness of the controls and procedures on an ongoing basis. So this would include regular security assessments, monitoring for security incidents, audits, things of that nature. Next slide. The workflow of information and decisions. So as you can see here on the left in the diagram, we have three main levels of decision making. Starting at the top, you've got the executives. In the middle, you have management, and at the bottom level are the operational folks. So the executives provide the strategic decision making. Management's more of a tactical area, and then the operational, you've got folks that are actually operating and they're making on the ground decisions. So as you can see there, we've got the executive level, includes the highest level of decision makers within the organization, such as the CEO, board of directors, or other C-suite executives for making long-term goals, overall direction of the company, etc. Management level, managers and other mid-level decision makers. These guys are responsible for making tactical decisions that support the organization's strategic goals and objectives. And on the operational level, this includes the frontline workers and other employees who are responsible for carrying out day-to-day operations of the organization. And they'll be making those frontline decisions that are on the ground as well. So the arrows in the diagram indicate the flow of information and decisions between the different levels. You've got flow on the left-hand side coming down from the executives, flowing to management, and management's flowing it to the operational folks. And on the other side, the reverse side of the coin, you've got the operational folks that are seeing things on the ground, flowing information up to the management, who are then flowing it up to executives, which then can make more decisions and complete the cycle over and over and over again ad nauseum. Critical cybersecurity needs to ensure Stark Industries' compliance with cybersecurity regulations like FISMA, NIST, SP 800-171, CMMC, and DFARS. The following critical cybersecurity needs are in place. Access controls. Access controls are fundamental to complying with FISMA, the NIST controls 800-171, CMMC, and DFARS. It involves controlling access to information systems and data by implementing authentication, authorization, and auditing mechanisms such as a mandatory access control policy, which classifies data from top secret down to unclassified. It is important to limit access to only authorized users and regularly review and audit those access controls. Incident response is another big one. All government contractors are required to have a well-defined incident response plan or IRP in place to comply with those regulations. Includes procedures for detecting, reporting, and responding to any cybersecurity incidents. It's essential to have a comprehensive plan that identifies roles and responsibilities, outlines the necessary steps to mitigate risks, and specifies the reporting requirements. Up next, data protection. Protecting sensitive and classified data is critical to Stark Industries, especially considering the information that the company handles. Data protection involves encrypting data at rest and in transit and implementing secure data destruction policies. The company uses strong encryption methods and limits data sharing to only authorized users. Up next, vulnerability management. Uh, Vulnerability management is another critical need for the company to ensure compliance with all the regulations. Regular vulnerability assessments and pen testing must be conducted to identify and remediate vulnerabilities that could be exploited by criminals, and this involves implementing automated security monitoring tools and security testing frameworks. And then finally, compliance with the cybersecurity frameworks. So obviously, that's another big one. Frameworks include the NIST 800-171, CMMC is a framework, and DFARS as well. These frameworks provide guidelines and best practices for managing and reducing cyber risks for DoD contractors and organizations connecting to federal systems. Next. Differentiation between the NIST and ISO. There are some differences between NIST and the ISO 27000 series in terms of their different focuses and approaches. The NIST CSF focuses on 5 core functions that were mentioned previously: identify, protect, detect, respond, and recover. It's a flexible and adaptable framework. It's highly tailorable to any organization that wants to use it. On the other hand, ISO 27000 series is an international standard. It provides a comprehensive framework for information security management systems. It's based on a plan, do, check, act cycle and provides detailed requirements for managing information security risks. And it's going to be less flexible than the NIST CSF. Organizational efforts, business needs, and outcomes. So the organizational efforts, primary efforts of the business are focused on continuing to capture new DoD contracts and deliver highly effective products to the warfighter. That's the whole purpose of the company. And besides making a profit, of course. Business needs to be successful. Stark Industries needs research and development. This is where we're coming up with the new weapon systems, new platforms, manufacturing and production to make those things that come up in research and development. Financial management, sales and marketing. Uh, we can't sell things to DoD or other government agencies without the financial team, the sales team, and the marketing team. Maintain regulatory compliance. Um, Without maintaining that compliance, Stark Industries would be out of business. And then finally, risk management is um, a huge thing for the company. Outcomes, the ideal outcomes include profitable ventures undertaken by the company and the success of its products in the field. Next, elements of a software assurance maturity model, according to OWASP. So we've got 7 different key functions here: governance, risk management, training and awareness, process improvement, quality assurance, verification and validation, and incident management. So these different elements make up the software assurance maturity model, or SAM, as OWASP refers to it. So governance, you're looking at establishing policies, procedures, and guidelines that govern software assurance practices. Risk management involves identifying and assessing risks associated with software development and deployment. Training and awareness involves providing training and awareness programs to ensure that employees and stakeholders understand how critical software assurance and organizations' policies and procedures are. Process improvement, continuously evaluating and improving software assurance processes to increase efficiency and effectiveness. Quality assurance, make sure that the software meets established quality standards and any defects are identified and corrected throughout the process. Verification and validation, this element involves verifying that software meets those requirements and validates that it functions as intended. And finally, incident management involves establishing procedures for identifying, reporting, and responding to incidents related to software assurance. And that is the end of this presentation. Here are the references for this presentation. Thank you very much for listening, and we'll see you next time.